So in this final video where we look at sine and cosine periodic functions, we're going to be looking at pre-rendered pictures, and we're going to be determining the amplitude, the period, and the equation for these graphs. Now, one of the great things about these graphs is they do not include any vertical shifting, nor do they include any phase shifting, so we don't have to concern ourselves with those. Those are a little bit on the tricky side, so we're just going to focus on finding the period and the amplitude and the equation. So the period here, the amplitude is the easiest part to find. So for part A, the amplitude, which is always reported as an absolute value, is going to be 2. And we can see that from the y-axis, because normally the y-axis would be 1 and -1. Now what we have to do is we have to take a look at the period. Now the period is going to be the distance from where it starts to where it starts repeating itself. So the period in this case is 4 pi, because it repeats itself from the high, medium, low, medium, high in 4 pi. So to get our equation, we can see that this is a cosine equation, because since we haven't done any phase shifting, we can't assume that this is a sine function, because it's you could say it's a sine function phase shifted, but we're not going to get into those possibilities. So this right here is a cosine wave, and what we need to do is we need to figure out from the period, we need to figure out what that coefficient would be in front of x, which is sometimes labeled as omega, and sometimes in books labeled as b. We have to figure out what that b variable is. So our answer for this problem is going to be something like y equals, and we're going to have 2, our amplitude, cosine something x. So we got to figure out what that something is. Now if you wanted to put 4 pi there, you'd be wrong, because the period is not the coefficient in front of x. There is a coefficient in front of x that adjusts to make this period, but putting the 4 pi in front of the x would be wrong. So let's figure this out by using our period equation. The period equation from the book is going to be 2 pi divided by the absolute value of b, which brings up the transitive property. The transitive property says if a is equal to b and a is equal to c, then a is equal to then b is equal to c. You'll notice that if period's equal to 4 pi and period's equal to 2 pi over b, we can find this missing letter b, which would go right here. This would be our letter b. We can find that by setting these two equal to each other and solving for b. So we have 4 pi is equal to 2 pi over b. And I don't have to worry about the absolute value symbols here, because we're not going to be working with any kind of negative rotation here. So we are going to now do some manipulation. Now the best manipulation I can do is by changing the position in the upper left-hand corner with the lower right-hand corner. I can do this because of the cross multiplication or means extremes property allows me to change the places of these without changing the actual answer. So I can rewrite this as I can rewrite this as b is over 1 is equal to 2 pi divided by 4 pi. And then I can just simplify 2 pi over 4 pi. Pi divided by pi is 1, and 2/4 simplified is 1/2. So my answer for this problem for b is 1/2. And that's my equation for this picture here. So if we take a look at this picture, our amplitude is also 2. Our period from here to here is also 4 pi. And to write my equation, this one looks like a sine wave. So y is equal to 2 sine, and I have to find my b, the number that goes in front of x. Well, we've kind of already done the work here, because you can see that the period, like this part of the equation that I just circled in green, or this part of my work that I circled in green, would just be duplicated, because we've went from a sine wave that went from a normal sine wave would have a period repeat every 2 pi. This repeats every 4 pi. And we can see that that was done over here, so we'd end up with 1/2. So if we look at the last example here, we can kind of do it a little quick because you can see that there's going to be a lot of similar characteristics. The amplitude, because of the y being 2 and 2, is 2. We always report the amplitude as an absolute value. The period is again 4 pi. And the equation in this case will be a cosine because it starts here and ends here to get me my 4 pi period. But as we write the equation, we gotta note one thing. You'll notice that it started negatively instead of positively. So that does in the equation change that, have a negative in front of that amplitude. Then we're gonna have cosine, and again, because of the period being 4 pi in each of these problems, we have 1/2 x. So in our last 3 examples, we have another wave here that starts here at 0, the origin, and repeats at 4 pi. So here we have an amplitude, amplitude of 2. We have a period equal to 4 pi. And then we're going to take a look at this equation. We're going to have y equals, and this is definitely a sine wave. But you'll notice that the sine wave goes down instead of up. So this is -2, and this is sine, and then this is going to be, thinking back to the previous 3 problems of the period of 4 pi, 1/2 x. Alright, now we're going to get to play with another different period here, because you'll notice instead of this amplitude being 2, seems like all of the amplitudes are 2 here, right? We now have a period that's exactly 4, which is a little odd, right? But we're going to be able to use our formula, because we have to figure out our y equals 2 cosine. Got to figure out that missing b there that goes in front of the x. And plugging the 4 right there would be wrong, because the letter in front of x is a period modifier and not actually period. So we have to use what we know about our period, because the period formula is 2 pi over b, technically the absolute value of b, and here we use our transitive property again. We can say that 4 is equal to 2 pi over b. And I'm going to put the 4 over 1 and use our cross multiplication trick to get the b moved over to this upper right hand corner and switch the 4 into the lower left hand corner. So this is going to give us b is equal to 2 pi divided by 4. In this case you won't have any simplification of the pi, but you can simplify the fraction as 1/2 or just pi over 2. So our answer is pi over 2. And we saw that in previous videos dealing with period adjustments. If we have a radian inside of b, it turns our x values into whole numbers. And this is going to line us up pretty nicely for our last problem here, because here we have a sine wave. The amplitude is 2, the period is 4, and we'll double check that by going from the origin to its first place where it starts to repeat itself. And then we have the equation y equals 2 sine pi over 2, because we have the same period as before here and here, pi over 2 x. So the reason why we're doing these problems is that I'm going to probably have some of these on the exam, the paper pencil part of the exam, because I really just want to focus on the amplitude, period, and then you thinking about from the picture what would that look like as a full equation. And that also means reverse engineering your letter b that would go in front of the x. So this skill definitely repeated on your take-home test or in-person, in-class test. All right, well, thank you so much for watching.